Then we have to use something called conditional probability, like the probability that the bus is late if it's raining. Let's say I keep track of the weather and the bus every day, every time I go to work for a long period of time. And I organize this data into something called a two-way table. So, most of the time, the sun was shining. In fact, the sun shone a total of 73 days. And it rained only 27 days. It was 100 days altogether. On the days when it rained, the bus was late 19 times and on time 8 times. When it didn't rain, the bus was late 20 times and on time 53 times. So how many times was the bus late altogether? 39. And it was on time 61 days. And once again, every row should add up to its total. Every column should add up to its total. There were 100 days altogether in the sample. 73 with no rain, 27 with rain. So, would you say that whether the bus is late depends on the weather? I would say so, because most of the rainy days the bus was late. Most of the sunny days the bus was on time. You can use this table to answer a wide variety of probability questions. For example, what's the probability that it rains? Well, it rained 27 days out of 100. Okay, here's a more interesting question. If it's raining, what's the probability that the bus will be late? Now, us crazy mathematicians have a shortcut for everything, so instead of that whole sentence, we'd write what is the probability of late given that it rains? This means the same as this. Now you know the notation. So we know that it's raining, so there's only 27 days that fit that pattern, and 19 of them had rain. This if, this given, it kind of tells you what your denominator is. Let's convert that to a decimal. 19 divided by 27. Okay. 70.4%, or sorry, 704. Okay, if it doesn't rain, what's the probability that the bus is late? So late given no rain. How do we do that? Well, we got to look at the no rain column, right? Late in the no rain column. (20 out of 73). 0.274. So, clearly the bus is more likely to be late if it's raining rather than if it's on time. So, now that we know what conditional probability is, this is conditional probability, now we can learn about the full version of the multiplication rule, the fancy version. The full multiplication rule says that the probability of A and B both happening is the probability of A happening times the probability that B happens when you know that A already happened. Let's look back at the markers. Got 6 markers. 3 of them are black. I mix them up. I draw a marker. I set it aside. I draw another marker. What's the probability that both of the ones I drew are black? So, what's the probability that the first one I draw is black? Same as it was before, 1/2. Half the markers are black. Actually, I'll write it as 3 out of 6. Now, I have drawn a black marker. It's over here. It's not in the pool anymore. If I draw a second marker, what's the probability that it's black? Oh, I've only got 2 black out of 5 markers. Multiply that, you get 1 out of 5. So the probability of drawing 2 black markers in a row is only 1/5. So that is conditional probability and the full version of the multiplication rule.